Hi guys, it's Miss Batty here, back with lesson 8 in our series on populations and resources. This is our second to last episode in the series on populations and resources. And I'm so excited to get to the end of all of our investigations and finally be able to make some recommendations to our ecologists about what is going on in our moon jelly populations. What you're going to need for the lesson today is a pencil or pen, some blank or lined paper to take notes, or if you have the packet pages available, now would be a great time to get those out. Something that's optional, but if you have access, would be to open up Amplify and the Populations and Resources digital model. We are going to be using this today for our final investigations, for our final pieces of evidence that we are collecting. As usual, I recommend that you open up a text or a chat with a friend, or maybe find somebody around the house that you can check in with to talk to about your ideas and thinking over the next 20 minutes of our lesson. Let's do a quick review of what we learned last time. Last time we started to think about this new type of relationship called competition. Let's put our thinking to the test with this scenario of the lion, the hyena, the zebra, and the grass. What do you think would happen to the lion population if the hyena population increases in size? Assume that the populations were stable before this change. So before I even look at the answers, I would probably begin by starting to annotate my food web with what I know, and then starting to think through it that way. So if you are able to do this, I want you to pause the video right now and take some time to think through this on your own, check in with that friend or that family member about it, and then come back and check in to see if we have the same ideas. All right, so I'm going to start by putting a little arrow next to my hyena because I know that population is increasing. The hyena population is increasing. That means their resource population, the zebras, will be eaten more because the hyenas need more energy storage molecules. That's going to mean more deaths in the zebra population, and that is going to cause an overall decrease in their population. Now, because these are in competition, the lion are also getting their energy storage molecules from the zebra. When these decrease, they have less energy storage molecules available to them. That means the lions are going to have less births, and that will cause a decrease in their population. So, I think that if the hyenas increase and are competing more with the lions than usual, that's going to create less energy storage molecules available for the lions, and it cause their deaths to stay the same, but their births to decrease. That is going to see an overall decrease in their population size. Were you thinking the same thing as me? We have learned so much, and it's really cool to be able to get to apply all of our learning to these different scenarios. Remember that this is an indirect effect, the result of one cause leading to another, kind of like dominoes falling over. We had this initial cause that then caused something else, that then caused something else. The lion and the hyena are not directly connected on the food web, but they still are able to have an effect on one another. Now, at the end of our last lesson, I asked you to think about if there could be any other indirect effects than just competition. And many of you were thinking that there could be. Some of you noticed in our last lesson that even though we were focusing on what happened to the furbals, there were changes that occurred to the greenleaf and the wee bug population. It seems like populations can affect each other even when they're not in competition. We're going to get back onto the digital model today to think a little bit more about this. We are going to collect evidence on whether affecting one population can have indirect effect on other populations in our ecosystem. If you have access to the digital model, pause the video right now and make sure you get there and open up the 6 population sim. Let's focus on 2 populations that don't have either a consumer or resource population or any competition. For example, the claw cats have no consumer population, so we cannot affect them by having them being eaten more. Let's see if we can find 2 ways that we can decrease their population by changing something else in the food web. The green leaves also have no resource population. They are something called producers, and they make their energy from the sun. We're going to learn about these in our matter and energy unit. If the sun is constant all year round, can we find 2 ways to decrease the green leaf populations? We don't have a way to affect their resource population and decrease their number of birds, but can we find other indirect ways to do this? Again, if you have the digital model open, go ahead and pause the video, skip over this part, and check back with us after you've done your own investigations. If not, follow along with me. All right, you guys, so here I am in the 6 populations digital model, got all my ecosystems set up, and I'm just gonna let the time run for a little bit and see kind of how things are as they are in our baseline. All right, so I'm going to pause here, and our first mission was trying to decrease the number of claw cats in 2 different ways. And so one way we already know would be to decrease the number of scale beaks. This would mean less energy storage molecules for the claw cats, and that would mean that they would be having less births, and they then would have a decrease in their population. So we need to think of another way because we don't really have something we can do to their consumer population. So I am going to try and affect one of these other populations. I wonder what would happen if we decrease the number of furballs in the population so that the scale beaks have nothing to eat. Will that eventually have an effect on the claw cats? Let's go ahead and try this out. So we really have no furballs. I don't see really any blue in our population. I'm still seeing our 4 claw cats. So we're still seeing they're there. But it is looking like they're not really able to do much. They're just kind of standing there. Their energy storage molecules are decreasing. Let's take a look. Yeah, again, they're not really being affected. It does look like our scale beaks are almost all gone though, which is going to be really interesting to see. Let's take a look. Only 2 scale beaks here. So our scale beaks are really decreasing in size. Their population is starting to really disappear. I also am noticing, and maybe somebody else's, look how many wee bugs are in the population. They are becoming out of control, which is really interesting. And the green leaves are also almost completely disappearing, which actually was one of our second missions. So I'm gonna pause it here and let's take a look at our analysis. So we started, everything is looking pretty stable. We've got our 6 different populations. We would say that there's some biodiversity in our ecosystem. At this point, I really decreased the number of, what did I do here? I decreased, the number of furbals in the population. And here we had about 7 scale beaks, which is important for us to know. As we went down and continued with the time, it happened pretty slowly, but as you're gonna see, this number of scale beaks is decreasing and decreasing and decreasing. After a while, it does take time, but then we start to see this decrease in the claw cats as well. So it does seem like messing with the resource population of the resource population of something does have an effect. Now, what's interesting here is when we were making this change, we actually also completed our other mission of affecting the green leaves. Note that at this point, they are at about 130, and by the end of our time, if we keep letting it running, there are only 20 green leaves left. Now, to try and understand why this might be happening, I noticed that the wee bug population just shot up, which means that they are needing way more energy storage molecules. If we take a look, right, the wee bugs are eating the green leaves. So if they are this big, they are really causing a lot of death in the green leaf population. So that is really interesting. By affecting this furball, we not only affected the claw cats, but we also affected the green leaves and the wee bugs. Things are starting to get really out of control and unstable in our ecosystem. Wow, you guys, we just realized that by changing one population, we actually were able to affect the scale beaks, the wee bugs, the green leaves, and the claw cats. I didn't really notice too much of a change for the stingwings, but I'm sure if we analyzed it further, we might see a change there as well. Just by making one change in one population, it seems like there's a chain reaction or some more indirect effects happening. The size of a population can be affected by any population that is connected to it in a food web, even if they are not directly connected. This is crazy, and this really is what it was talking about in the article, that biodiversity, or having many different types of populations working together and staying in balance, is really a great measure of the health of an ecosystem. When we started to decrease those furbals, lots of things started to become unstable and change very quickly. So, what does this mean for our moon jelly populations? There are many populations in the ecosystem. How could a change to these other non-resource or consumer populations affect the moon jellies and contribute to this increase? What I would like us to do is think about some of these before we look at the evidence next time. I encourage you to pause the video, write down your own notes, make your own annotations on a food web, and then check back in with my thinking. Let's get started. All right, you guys, so hopefully you've paused the video, you have written out your own thinking about what this change could look like. And so now you're checking your answers against mine. As we mentioned, our focus population is the algae. Now that is the resource population of the moon jellies. For an increase in the moon jellies to occur, we know that there would have to be an increase in the zooplankton to be causing more births to occur. So I'm going to add that little note for myself by saying that this would need to happen. For the zooplankton to increase in size, they would need more energy storage molecules available to them to have more births. So that would mean there would need to be more algae. If we find evidence that there is increasing algae populations, this could mean that it has contributed to the moon jelly increase in population. Let's think about the walleye polyp. Again, pause that video, think about your own thoughts, share them with that friend or family member, and then check yourself with my thinking. All right, so here we have our walleye polyp. This is a competition relationship. Again, we're thinking about ways that the walleye polyp could be connected to the moon jelly increase. Again, we know that the moon jelly is increasing. Now, they're sharing a resource population. This means that we would want to see an increase in the zooplankton because the moon jellies are most likely having more births. So how could the walleye polyp be changed to allow for an increase in the zooplankton population? There would be more of them because there would be less walleye polyp. Less walleye polyp would allow for more zooplankton because less deaths are happening when less energy storage molecules are required. So, if we see a decrease in the walleye polyp populations, this could have contributed to the moon jelly population increase. Let's think about the orca. The orcas are the consumer populations of the consumer population of the moon jelly. Pause that video again and think about your ideas. All right, so now we're kind of looking at it from a different way. This side of the food web is affecting the moon jellies more by increasing or decreasing their deaths. If the moon jellies are increasing, that would indicate that they are most likely having less deaths than usual. That would mean we would have to see a decrease in the sea turtles because less energy storage molecules required from the sea turtles means less deaths in the moon jellies. So what could have happened to the orcas to cause this decrease in the sea turtles? Well, if the orcas were increasing, that would cause this decrease that we are hoping for in the sea turtles because when they need more energy storage molecules, more sea turtles are going to be eaten, more deaths are occurring, and the population decreases. The last part of our food web is not actually connected in any way. The kelp and the sea urchin are not consumer or resource populations of anything else. Can you think of any ways that they might have still affected the moon jelly populations? They wouldn't have affected the moon jellies by eating more and causing more deaths or being eaten more and causing more births, but as we were thinking about before, they still are in the ecosystem. Maybe they are competing in a different way for space or other resources. That could be something to look at in further lessons. We have collected so much evidence in this unit, and I'm really starting to see how complex and intertwined these ecosystems are. There are so many different parts that all work together to maintain a healthy and biodiverse ecosystem. In our next lesson, we are going to see if there is any more population evidence for any of the other populations in the ecosystem. Then we will make our final recommendations to the ecologists for what we think is happening to the moon jellies and how it is occurring. You guys have done such great jobs as scientists, collecting evidence, analyzing and interpreting evidence, thinking about how this could affect different scenarios. I'm so excited to look at our final pieces of evidence with you next time and come to a conclusion. See ya!